again to another Java short tutorial. And in this Java short tutorial I'm going to continue to build on the topic of inheritance by talking about abstract classes. In a previous tutorial I have spoken about method overriding, which essentially means that, for example, in the class person, which has a method called display information, which is used to, well, print the information of person. We have a class called staff, which extends from person and therefore has all the information and methods available of the person class, and also overrides the display information method. Why? Because person has name, age, address and phone number. In case of staff we also have years of service, which we want to have included in the display information. So in a previous video I've shown how method overriding can be used to have different implementations on different inheritance levels. And today I'm going to continue to build on that by introducing the abstract class. Okay, let me first just get started by creating a class called bank account, which is going to serve as the superclass in this particular example. So bank account has a account holder name, has a account number, and has a amount. And basically I can generate getters and setters for that. And naturally I can create a amount a method called calculate interest. Which will basically calculate the interest over the amount. Okay, well, this method pretty much becomes a bit of a problem because different bank accounts have different interest rates, and there's no such thing as a generic interest rate for bank account. So I can define a method in bank account, but inevitably it will become overwritten by specific bank accounts. So one thing to rectify this in a tidy manner and avoid creating a superclass that can in reality never have an instance created of it, you can create a abstract class. And you can do that by adding the word abstract in front of class. A abstract class can serve like any other class in terms of inheritance, save for the fact that you cannot create an instance of bank account, as you will see later. So basically I have my abstract class bank account, I have my usual attributes and my usual methods. And one last thing, which is a requirement for abstract class, is that we have a abstract method. So in this case I'm creating a abstract method called calculate interest, which returns a double. And because it's an abstract method, I am not going to create a implementation of this method. Okay, so this is as far as the superclass bank account goes. So basically you can still create attributes, methods, but you cannot create an instance of it because of the word abstract, and you must have at least one abstract method. Okay, now let's go to let's create another class, a subclass in this case, called savings account. So savings account is a type of bank account, so extends bank account. And as you can see, I'm straight away getting an error message. That's because I have defined a abstract method in here, therefore I must implement it in this class. So I can use my autocompletion in this case, in which it indeed shows, hey, I must implement a calculate interest. One last thing, what would I like to add? Well, in anything I want to store about a savings account. Not really. Let's just focus on the calculating of the interest. So in this particular case, I'm gonna declare a double variable interest rate, which I'm gonna set to, let's say, 2%. So in this case that can be an integer. Well, let's make it a double. 2%. So in this particular case I need to return the interest. So the interest would be in a very simple calculation. Okay, let's get the amount from the superclass times the percentage, so basically the interest rate divided by 100. So there we go. Okay, now let's create a test class in this particular case. So that will be test bank account, which has a main method. Okay, one last thing to speed things up. Let me create a bunch of constructors for these classes. This dot account holder name is null. This dot account number equals null, and the amount is 0. Let's do the overloaded constructor. There we go. So inside the savings account, let's create also a constructor. Which in case of the default constructor will just invoke the superclass constructor. In this case, name, number and amount. Name, number and amount. So there we go. Okay, now back to the test class. So first, like I said, I cannot create an instance of an abstract class. So if I attempt to create an instance of bank account, I will end up getting an error message. And this error message says cannot instantiate the type bank account. Why? Abstract class. So in this particular case I need to create an instance of savings account. And in this case I will use the overloaded constructor. So John Smith, who has bank account number 123-456-1 and has a amount there of $120.95. Okay, so just to prove that this works, let's print the name. And print the interest. Calculate interest. Okay, now let's see what happens if I run this. Okay, John Smith, who has, well, $2.40 something interest, so that's about correct. So, okay, so basically we have a superclass bank account, a subclass savings account. Let's create one more class called current account. And current account in this particular case will also be making use of the constructor of the superclass. Of course I can create my own attributes. Well, okay, let's do that then. Let's create a private, just to indicate the difference, string company name. Say if the bank account belongs to a company. So then it becomes this dot company name equals null. Okay, then for the overloaded constructor, so that will be the name again, the number, the amount, and in this case company name. And of course I should not forget the data types. So again, invoke the superconstructor, name, number, amount, and in this case set the company name to the provided comp name. Okay, what did I miss out this time? Oh, naturally I cannot invoke a superconstructor unless I do the actual inheritance. So extend from bank account and implement our calculate interest method. So in this particular case, I don't want to have an interest rate of 2.0. I want to have an interest rate of 2.50. So again, I'm going to say return super dot get amount times 100. Interest rate divided by 100. Okay, so in this particular case, I'm going to create a current account instance, and I'm going to provide the exact, well, I'm not going to provide the exact same amount, but a different name, Jane Smith, with a slightly different account number. I want to do the same amount, and the company name would be Matt Saylor Software. Alright, let's enlarge this a bit. Okay, so again, I am going to do some printing. So the account holder name. Next to that, I would like to print the company name. For which I forgot to generate a getter and setter, so let's do that right now. So company name, there we go. So that would be ACC1 get, ACC2. That's what happens if you have very similar classes. Get company name, and then finally calculate interest. So let's run it one more time. Okay, we have John Smith here, followed by Jane Smith from Matt Saylor Software, who has a slightly better interest on the same amount. So as you can see, I have two classes inheriting from the same abstract class, therefore being forced to implement the calculate interest method in their own way with their own interest amount. Because it makes no sense to create an instance of bank account, given that we beta the abstract class, we cannot instantiate it. So there you have it, abstract classes in a nutshell. See you next time.